Today, I'm going to go over deriving functions using the product rule. So the product rule is amazing for deriving functions that look something like this, where you have two different functions we can call this first bracket f at x and the second one g at x, multiplied together to give you h at x. So we could expand this out and use the power rule, but that would take a lot of time. It's a monstrosity, so we're not going to do that. Instead, we can use the product rule. So what is the product rule for, say, for functions like this? Well, we have h at x is equal to, essentially, we can call it f at x times g at x, or for simplicity's sake, I'm going to write f times g. So when deriving functions like f times g, we get the following. We get the first function, so this f at x derived, multiplied by the normal g at x not derived, plus the derivation of g at x, so this derived, multiplied by f, so this left underived. So that's the product rule. So let's derive this function. I'm going to copy and paste it so I can read it down here. So let's bring it down a little bit more, like that. Yeah, good. Oh, shoot. There we go. So I can do this all in one line. So what's the derivative of this? So let's do it simply. 6x minus 5. And then we multiply that by this function, left underived, like this. Keep messing up my writing. Plus, and then this equation derived would be 9 times 3, 27x squared, minus 10x, plus 63. Constants, the derivative of constants are still 0, and then multiplied by the first part. Simply, just like that. Now we could expand and simplify, but do you really want to? I don't think you do. Lots of questions that look like this, that have huge functions like this, will just say, derive in one line, you don't have to simplify. Now, what about functions that have three parts? Let's say h at x is equal to x squared plus 4, x to the 5 minus x, and then times 3x minus 2. Something like this. Well, the product rule can be expanded for three different functions as well. So I'll make this I at x. So when we have f times g times h, the derivative of that is still, you still have this, the derivative of f, of this first one, multiplied by the other two, and then the derivative of g multiplied by the other two, and then the derivative of h multiplied by the other two. So that would be the form for 3, and you could do the same sort of thing with a function with 4 parts. So I prime at x, this would be, we would derive this part, which would be 2x times x to the 5 minus x, 3x minus 2, and then we derive this part, which would be 5x to the 4 minus 1 times x squared plus 4, we're multiplying by the other parts, 3x minus 2, and then we're going to derive the last part right here, so this would be 3 times x squared plus 4, and x to the 5 minus x. Good. Now let's just do one little proof thing to show that the product rule is valid. So let's say we just have a basic function f at x is equal to x plus 1, x minus 1. So first we're going to use power rule. We're going to first expand it out. So this is a difference of squares, so we get x squared minus 1. And when we derive that, we just simply get 2x. Simple. But let's say we don't want to use the power rule. Let's say we use the product rule. So f prime at x would then equal, the derivative of this would be 1 times and then x minus 1. And then plus the derivative of this, of the second term, would be x, would just be 1 times and then x plus 1. When we expand that out, just basically getting rid of the brackets, we can clearly see that these two terms cancel out, and we are left with x plus x is equal to 2x. So we get the same thing, It doesn't matter in this instance if you use the power rule or if you use the product rule. Generally, what I like to say is if you have a basic function like this that's basically like a quadratic or even a cubic that's just factored like that, super easy to expand, use the power rule, it's easier. But if it's something more complicated like the above functions, then I would just use the product rule. I hope this video has been helpful for you. Thank you so much for watching and have a good day.